Good morning, good afternoon, good evening, wherever you are in the world right now. This is the OPC Foundation. We are at the OPC Day International 2022, and it's a pleasure to welcome you again for the day two. We had an exciting start yesterday on day one. We had the agenda completely committed to the energy transformation, alerting us what is really the need and immediately action to take care, and the role what OPC UA plays. I was really even speechless when I learned what huge efforts have been made and are made to involve OPC UA to be part of the largest wind solar panel project, the largest wind turbine project, or capturing carbon and store it, or in the building automation project in Ingolstadt. So we had an amazing first day. Today, on the day two, we are more focusing on the core technology. On the first block, it's more security, but then we talk about cloud and field. I will introduce that a little bit later on more in depth. Let's have a quick look. Let's have a quick look on day three, where we are focusing more on the collaborations, where we talk about the semantics, what we do with partners, so don't miss that session tomorrow on Wednesday. Looking to Thursday, day four, it is more on solutions and applications. I highly recommend to listen to the first speaker, to Jim Lutz, because he's exactly explaining if you have multiple devices, not just two, a client and a server talking to each other, multiple devices in a big plant and a factory, how can you discover them, how can you connect them secure, how do you find them? That's really amazing. Obviously also all the other presentations with MQTT, with how does it interact with the asset shell, asset administration shell, and we get exciting end user success stories here from Predictor and L'Oreal. And a pre-look on day five, we are answering all the questions you ask us. The how-to day with super short explanations, not on deep developer level, but on explanation level, helping you to understand what's really important. But let's start today with the day two of the OPC Day International. Again, we have a first block focusing on security, then a second block on cloud, and after that on field activities. We already mentioned yesterday that security is an ongoing process, is not just given once and then it is there forever. It is an ongoing process, and this is what we are proud to have in place. But I'm handing over and introducing Randy Armstrong. He's the first speaker, and he's explaining you exactly what is the process inside the OPC Foundation, but also what is coming up as new security features and functionalities to be proven, have proven technology for the future. Randy, welcome.
Of the OPC UA Security Working Group. And I'd like to talk to you today about preparing OPC UA applications for ECC. I'm also going to touch a bit on the overall process that the OPC Foundation uses for managing security issues. So one of the challenges of the security environment is it's constantly changing. Cyber attacks occur, vulnerabilities are reported. National agencies such as BSI in Germany or NIST in the United States provide recommendations on security and the constant march of technological change. And in order to manage all of this information that's coming at us, the OPC Foundation set up a team of 25 or more security specialists from all different member companies that meet every week to discuss whatever has come up most recently, and develop plans and strategies for dealing with any issues that have appeared. And these strategies can include new features such as the ECC, which we'll be getting into in a bit, specification errata when deficiencies have been identified in the specification that could either lead to insecure implementations because of lack of clarity or other sorts of problems like that. If software has been affected, we will prepare CSVs and we'll coordinate with vendors who are using that software to make sure that their products are updated and their patches are ready to go when we release the CVE. And we'll provide input into the compliance testing group to help them develop better tests to ensure that certified applications are secure and meet the OPC security requirements. Now, before I get into the details of the ECC implementation in OPC UA, I want to sort of put it in the proper context where I explain how ECC is used within UA. Specifically, all communication in OPC UA it requires privacy and integrity, and the peers must be able to authenticate each other. And this process requires that each application have a key. Public key cryptography refers to a set of algorithms that are based on public-private key pairs, where the private key is a secret known only to the application, and the public key is information that can be exchanged with the peers. And public key cryptography provides a convenient way for applications that haven't been pre-configured with knowledge of each other to be able to communicate securely. RSA and ECC are public key algorithms used by OPC. The RSA algorithm is the algorithm that is used by all applications today. It is a very good algorithm. It provides the security that we need. The main issue is the bit length, which is now the minimum required bit length is over 2,000 bits. 8 years from now, 2030, that bit length will go up to 3,000 bits. These are based on the recommendations provided by NIST. And from there, it could, depending on how the computing resources evolve, it could go even higher. Now, longer bit lengths mean more memory, larger messages, more CPU. And today, there are limited resource devices that cannot implement OPC UA security because of these long key lengths. Or if they do implement it, it just takes an insane amount of time for the security handshake to complete. Elliptic curve cryptography provides an alternative. It provides equivalent security with much shorter keys, almost as 10 times smaller in many cases. And that ultimately is why ECC is the future of cryptography with OPC UA. Now, interoperability with ECC requires that both sides agree on the same curve. Now, there are theoretically an infinite number of curves, but the industry has defined a number of standard curves that have been thoroughly examined by cryptography experts to determine if they're suitable for cryptography applications. And out of those curves, the OPC UA has selected 2 families, and within each family we have a normal strength curve and a strong strength curve, basically a longer bit length. Now, the NIST curves are the most widely used. Their implementations are used almost everywhere. In a lot of cases, when people talk about ECC, the presumption is you're using the NIST curve. Unfortunately, it is sponsored by a U.S. government agency, which means there's places in the world which don't trust the U.S. government agencies and they would refuse to use NIST, which is why it's important to have an alternative. And those alternatives are the curve 25519 and curve 448. These are sometimes called the Bernstein curves. They are very good curves for implementation on constrained devices because they can be implemented efficiently without any particular hardware support. Unfortunately, there's some very big gaps in coverage. Some platforms do not support these curves, and it may be some time before they do. So what that means is that we weren't able to mandate that curve 25519 be used everywhere. We had to come up with a profile that allows a implementer on a constrained device to choose one or the other. And the hope is, over time, the implementation gap with 25519 will disappear, and then we'll have every device will be able to implement both curves to sort of maximize interoperability. And another reason to have both curves is you have a fallback if one of the curves is compromised for one reason or another. Of course, any device that is not resource constrained, the recommendation would be to support all four curves. Now, in sort of following on the trend when it was mentioned before about how the OPC UA Security Working Group reacts to cyber threats or cyber attacks that get reported, and we look at these things and figure out what changes are needed for OPC UA. The Heartbleed exploit that for OpenSSL was discovered a number of years ago. We figured out that it didn't directly affect OPC UA because RSA already had a partial solution. But the industry standard now is to require perfect forward secrecy. This is basically an algorithm that allows for data encrypted today to be protected even if the keys of one of the partners has been compromised in the future. And so OPC with ECC has a complete PFS solution, and it's mandatory, and it's just an example of how OPC UA is evolving as technology evolves, and basically as industry requirements change and as industry expectations change. Now, when you actually want to establish an OPC UA communication with ECC, you need to have a certificate, and each curve supported by an application requires a different certificate. So an application that supported all four curves and RSA would need to have 5 certificates. So the handshake that's already in place with OPC UA, where you call get endpoints, you get back a list of endpoints with a security policy URI and a certificate, already provides a mechanism for the client to get all the certificates that the server has available for use with the different ECC algorithms. It would then pick one of those certificates that matches what it has, and then would use that to create the session. And then the rest of the session would go on using the algorithm selected by the client. Now, one of the complexities with ECC is ECC does not provide encryption directly. It requires the use of a handshake with ephemeral keys. And so this required a slight extension to the handshake that's used by all UA applications. So what happens here is we already have this. Whenever you're passing in a user identity token, you're going to first be calling a create session, then you're going to call activate session. Each time you want to change your user identity token, you call activate session again. So the mechanisms that with ECCs, you'll have to pass in the security profile that you want to use to encrypt your user identity tokens when you create the session. And after that, each time you call either the initial create session call or each time you call activate session, you'll get back an ephemeral key which must be used to construct the secret the next secret that is passed into activate session. So this is a slightly more complex handshake, but it doesn't change any of the overall APIs that the OPC UA is defined, and SDK should be able to handle this transparently within their code. So the application developer doesn't really care. They'll simply provide the user identity token as they've always provided it, and the SDK will take care of the additional complexities with ECC. Now, as you probably sort of realized when I was talking about 5 certificates for each individual applications, that the introducing ECC into a network can potentially make management of the certificates much more cumbersome. And this means that a certificate manager has become a practical requirement for any ECC installation. Now, certificate manager is often called a GDS, but it is an API to the PKI infrastructure that is available in a particular factory. And it allows OPC UA applications to use OPC UA APIs, specifically method calls, to get the certificates and trust lists that they need. So there's 2 different APIs. There's an API called the push management that servers implement, and it allows the certificate manager to connect to the server and provide the server with all the certificates that it needs and all the trust lists that it needs. The certificate manager also allows a pull management mode where clients connect to the certificate manager and request the certificates that they need as well as the trust lists. So any application will have to choose which mode they want to support, or if they want to support both modes, and then they can and then once they've done that, they can then interact with any vendor's implementation of a certificate manager. And there are a number of vendor implementations that are coming on the market now. Another place where ECC is going to show up is with the device onboarding specification. Device onboarding will be released as part of 1.052, and it allows devices to be plugged into the network and automatically configured and provided with all the certificates they need without the need for any human intervention. However, this mechanism, to be done securely, requires that devices be authenticated with a certificate that is installed by the manufacturer, called the Device Identity Certificate. Now, this Device Identity Certificate has requirements that are specified by other standards, and these standards are ECC. These standards require ECC. And so when you get into any kind of implementation with device onboarding, you're going to end up with ECC certificates showing up. So what are the next steps for a vendor with an application that you'd like to support ECC with? Well, the first thing is you'll have to figure out whether the SDK you're using, either a commercial or open source one, has released their ECC support. Some have already done this, and others the support is coming soon. And so when that support is available, you'll be able to upgrade your application fairly easily. There are no changes to the top level APIs, so your application will, after linking to the new version of the SDK, you will have access to the ECC capabilities. The one area where you may require some code changes will be in your configuration section. If you have assumed that you could only have one certificate for your application, you'll need to change those configuration UIs to handle multiple certificates. You will also need to add support in for certificate managers if you don't already have that. It's not going to be an option, even though its support is technically optional. It's not a practical option if you want to have a usable product as far as people are as far as your end users are concerned. So most SDKs have at least helper functions for these capabilities, if not complete implementations when it comes to for servers with push management. So this actually may be fairly easy to do for you. And so you basically that's it. Once you've sort of pulled those things together, you'll have support for ECC, and you'll be able to ship your upgraded products. Now, it's important to remember that the technical details of ECC and RSA are not things that end users should have to know or care about. And this is ultimately the purpose of all of this infrastructure, like the certificate managers that we're talking about putting in, is making sure that all of this management, all of this details of security algorithms could all be hidden by the vendor applications and things just work. And that is the ultimate goal. And when you're developing your software, you should be always thinking about what do you have to do to make sure that goal is achieved. Well, thank you very much for listening, and I hope you found it useful. Have a good day.
Wow, Randy, thank you very much. I learned a couple of things. Number one, you described really well the efforts what the OPC Foundation under your lead with all help of 20, 25 people around the world do weekly behind the curtain, so please continue. Second, ECC is more efficient if the key length is shrinking, while to my knowledge this is also good for small hardware constrained devices, embedded devices with less CPU power, so always good. And yeah, you mentioned also that's quite complicated behind the curtain, but overall maybe people and users, integrators don't have to know the details. That's what I absolutely agree, but overall they have to take care and be aware what are the steps to do and how to configure. Randy, thank you very much. You are already answering a lot of questions behind the curtain here. I'm asking the audience to continue starting questions in the Q&A, but I like to also hand over to the next speaker with the topic security. I'm welcoming Mr. Jens Cordt from the BSI in Germany, and we have been in contact with the BSI a couple of years ago. I think it started 2014-15, where they started because of the relevance of OPC UA for the German Industry 4.0 initiative, being selected as the one and only communication protocol at that time, which is documented in requirements for Industry 4.0 in a June 2015 document. So the BSI analyzed at that time the specification, but also code, and the BSI made a study on this. We had them as speakers a couple of years ago on an OPC Day Europe, but I'm welcoming today Jens Cordt to get an update on what they have analyzed now. It's your stage.
Welcome to the talk update of the IT security study on OPC UA. My name is Jens Cordt from the Federal Agency for Information Security. I will give you an update on the results of the new study that we have done during the last year. In 2015, the Federal Agency for Information Security did a first review of OPC UA. after Stuxnet in 2010, cybersecurity moved into focus of industrial control systems. So in the past, most of the ICS protocols don't have any security functions. So this was a problem, and OPC UA seemed like a legitimate solution for this problem. So because OPC UA claimed to provide security functions and be secure. And so we decided to do a first study. This study was started in 2016, and we wanted to check the specifications and wanted to know if the claimed security in OPC UA is correct and is doing a good job. As already said, the project started in 2015 with the evaluation of the specification. Back then it was the version 1.0.2, and we also checked or did a source code review of the C implementation that was provided by the OPC Foundation. So the results of the study were that we couldn't find any systematic errors in the specification. So this means there were no misuse of cryptographic parameters or something like that. Some recommendations were added in the following versions of the specification of OPC UA, like adding elliptic curves and adding more hash algorithms and something like that. But this was just kind of evaluation and adding new algorithms to keep the specification up to date. So no systematic errors, as already said. So, and some minor problems in the reference implementation were also found, but they were really fast fixed by the OPC Foundation, and so there was some good feeling on the security mechanisms that were present in OPC UA. So since 2016, time goes by. Now we have 2022, and the specification evolved. There were new features, there were updates on the specifications, and in 2020 we thought, okay, it's a good point to do an update on this review, and we started to prepare the project and start the new evaluation. Also, the usage of OPC UA increased, but where light is, there's also shadow, and yeah, some problems became obvious. And one of the most problematic issues is that the security mode sign or sign encrypt are hardly used. And yeah, that's especially these security modes are one of the key elements of the security features in OPC UA. the question was, why are these features not used so much? Another problem was the certificate management. When using the security mode sign-in or sign-in encrypt, you have to provide these certificates to validate the signatures or to encrypt the data. And in many cases, this certificate management was done manually, or it was hard to change the certificates, and there was no automation of this process. One reason for this was that no global discovery server that was specified was publicly available. So there was no real implementation of that. And yeah, that was and so two questions came up by us, and OPC UA is still secure with all these changes to the specification, with adding new features, with changing processes or features. And the second question was, why is it so hard for operators to use these security features? And that was the main reasons why we decided to update the security analysis. So looking on new features and looking on changes in the specifications, and to extend it and to look on the implementations and to do a kind of market study and look what security features are provided and why are there these problems according to using these security features. So the goals of the security analysis, of the second security analysis, were check the changes of the specification. At that point, the version 1.04 was the actual state. We did not include the pub/sub feature into the analysis because it would be too big for the budget that we have to do this analysis. And so we excluded the pub/sub part and just focused on the existing communication that was already analyzed in the previous study. And we tried to do another study on pub/sub, but there's no final decision to do that at the moment. And we also did a source code check and fuzzing on an open source implementation, and we did also a market analysis of available product in terms of security functions. So what do developers take care of during development, which security features are implemented, and so on. So with regard to the specifications, it's no surprise we didn't find any systematic errors in the specification, in the new specifications, and we provided recommendations for clarifications of the specifications, so that it will be easier for developers and implementers of the specification to use them and to avoid errors or problems or misinterpretations of the specification. I want to give some results of the market study also. And because of that, we also asked if it is planned to do an update from the older versions of OPC UA to a newer one. And yeah, most of the vendors planned to do an update and to support new versions. But we also see 1/3 of the vendors said, no, we don't plan to support newer versions or to update these devices to newer versions. So we see that some devices will stay on, maybe older versions of the specifications. And when looking into this, we see that some maybe really old versions are out there and are implemented in devices that are actually sold. So there are some devices that only implement the specification 1 or 1.01. And yeah, when looking back to the study of 2015, there were some algorithms that are not secure anymore. And when looking to security, updates are kind of a key feature to protect against new threats and to failures in the implementation. And I would hope that more vendors are planning to update to new specification or to corrections of the specification and to provide secure products and implementation. And when looking to the authentication that the products provide, you can see that most of the products provide username and password, or probably the use of anonymous. And when looking on the authentication methods that the products support, you can see most provide username and password, or they provide anonymous usage. Username and password you can use, but it's not the best way, probably, because it's hard to manage the passwords and to change them on a lot of different devices. And then looking on certificate-based authentication, you can see that maybe only support this kind of authentication methods in their products. So when looking on these numbers, I have to say that probably this is not a representative survey. As you can see, we had 79 answers on these questions, and there are probably a lot more OPC UA products out there, and maybe a lot more support the authentication with certificate. But you can see kind of a trend, and that is that we have security features specified, but they are not implemented in product. Users can't use them, or integrators can't integrate these security mechanisms in their machines. And we had another question on authentication and authorization according to user access level on different nodes in the tree. And this also shows that only 50% implement features like that, and the other 50% doesn't implement that feature. This is probably a real small part of the specifications and maybe a feature that is not often used, as you can see on the number of answers we got to this question. But as I said with the authentication methods previously, we have security features specified and they are not implemented. And this is kind of a problem. And we probably have a secure protocol with good security features, but it doesn't help when these security features are specified and not implemented. Yeah, and when digging deeper into these kind of security features, you see that role-based security is implemented even fewer in product. So we see it from the authentication methods based on certificates. That is not widely implemented. We see it on restrictions on the access level. It's not widely implemented. And when looking on role-based access or something like that, it's get even fewer. So from the answers, maybe only 1/3 have said yes, we have that feature implemented, and most vendors didn't implement it. And so I will come to a kind of conclusion, and I mentioned it in the first part. We have a specification that describes security features that are really good and they should work and protect the data that are transferred, and they are good for the usage or for the different use cases, and they use the right algorithms, they use the right techniques, and also and describe them in the right way, and they provide all features that need to be there. But when looking into the practical implementations and when looking into product, there is kind of a gap between the specifications of the security features and the security and in the practical doing and usage of it. So this is probably one of the biggest tasks that we all have together. We need to implement usable security. So security must be a supporting thing in the back of your product, and it must be easily usable for your customers. And the usage of the security features must be fostered. So it must be easy to use them, and in the manuals of your products you have to describe the correct usage of it, and there have to also be secure default settings. So when you roll out your product, there should be secure default settings. So it's not easy for your customers to use the product in a not secure manner. And one of the key elements to protect against attacks and weaknesses are updates. Updates have to be provided to your customers. You have to inform your customers about weaknesses and vulnerabilities in your products. And so the study, the full results of the study can be freely downloaded on the website of the German BSI. At the moment there's only a German version available. We are working on a translation at the moment, and I hope that we can provide them until the Hannover Messe, and the document will also be available on our website for a free download. And you're welcome to send me an email to get a reminder when the study is ready for download, and then I will give you a hint where you can find the document to download it. Yes, thank you for your attention, and have a nice day. Bye.
Mr. Cordt, thank you very much for your presentation and the feedback on the analysis. Obviously, the OPC Foundation also is publishing the document. You just go to the OPC Foundation web/security and you find all comprehensive material, also the videos from Randy Armstrong about security, but also the first and the second study for sure. And obviously, I'm absolutely supporting what you mentioned. It's not only to have great security mechanisms, implementers, integrators, end users have to make sure to activate them and make use of them. And with respect to the upcoming Hannover trade show, please join the OPC Foundation booth, because we are exactly showing GDS servers live in action. Experts are on the booth. And I'm aware that you, Mr. Cordt, are also with your booth in a close location in the same hall. So if people here from the audience like to talk to you, it's pretty easy to get in contact to both to you, but also to us. Again, thank you very much. The next presentation is about OPC UA in combination with MQTT. I introduced this a little bit yesterday already. Short reminder, there's not one single protocol which is completely fulfilling all requirements from the field level, deterministic transport, functional safety, motion, up to cloud scenarios. And this is why OPC UA is exactly a framework where you standardize information and then use different underlying IT infrastructure and protocols to exchange these information. We love MQTT, but I reminded everybody that some of the vendors already started doing own mappings, and I sent out a big warning on, hey, this will result in a big zoo of MQTT mappings, and it is more and more efforts, increasing efforts in the field to write small applications and wrappers to migrate data from one data format into another data format. And all this doesn't make any sense, at least for me personally. So the OPC Foundation has OPC UA over MQTT defined in the PubSub spec in February 2018, published as an IEC specification. So let's dive more deeper and learn more. And again, Randy Armstrong is our expert on this. And I'm welcoming and giving again and handing over to Randy. Randy, it's your floor.
Good day, my name is Randy Armstrong and I'm the chair of the OPC UA Security Working Group. Today I want to talk to you about OPC UA over MQTT. Specifically, I want to talk to you about topic trees, metadata, and the link to the OPC UA Cloud Library. Now, it's worth talking a bit about OPC UA over MQTT and its relationship to OPC UA client server and the PubSub technology. Now, PubSub itself is a generic mechanism that will work over any middleware, including UDP, including any type of broker-based communication. OPC PubSub over MQTT is a mapping that incorporates MQTT features into UA PubSub. So allow users of that mapping to take advantage of some of the unique capabilities of MQTT, which we'll be talking about later in this discussion. Now, the important thing to remember about UA PubSub is it's an extension to client server. It doesn't replace client server. In fact, in any system, you're going to have tasks that need to be done that are best handled with request response. tasks such as browsing the server address space, where you're navigating down a tree and following references to between different nodes. That is really done well with client server. But in other cases, if you just want to push a large volume of data up to the cloud, a broker is a very good solution. So any real system is going to have a combination of client server and pub sub. And OPC UA is the only technology that allows you to seamlessly integrate and switch between those two modes of communication. So that sort of touches on one of the bigger reasons why OPC UA, you'd want to use OPC UA with MQTT. But in sort of a general higher level view, it supports for multiple protocols. It supports binary and JSON encodings. Binary if you want to have a much more compact, efficient format. It supports end-to-end security with the binary. It also has a standard configuration information model and file format. This is much more important than people realize. A lot of systems that are built with MQTT today involve putting a lot of custom code on a bunch of different devices to push messages that were designed based on what the subscribers needed in that particular system. This code, so after this code is done, the system basically works, but you end up with maybe hundreds of devices that all have to be manually configured. This is going to be very difficult. These kinds of systems are going to be very difficult to maintain in the long run. OPC UA offers a solution to that, with a standard pub/sub configuration information model, as well as a way to represent the configuration in a compact file that can be uploaded or downloaded from machines. The information model combined with an OPC UA server running on devices allows the configuration of every publisher and subscriber to be remotely managed by tools developed for the task. And most importantly, you can have a tool developed by one vendor be able to configure a publisher created by another vendor. The other big feature of OPC UA with MQTT is integration with OPC UA information models. And these information models are a big part of OPC UA because they allow servers, basically sources of data, to express their information with rich semantic context. And this context is in part comes from the base OPC UA specification, but also from the many companion specs for different verticals, from robots to PLCs to kitchen equipment to pumps and many more. All of these different verticals have created standard information models. So you can have a robot by one vendor will look just like a robot from another vendor, and this gives a new level of interoperability to between applications that we never had before. And you get that integration with OPC UA over MQTT. And this is particularly important because there's no need to take the information models, and a lot of times people sort of assume you take this information out of the information models, put it into some intermediate format, and you lose all this information when it's sent over the broker. You don't need to do that anymore. Now, the OPC UA over MQTT mapping includes a recommended set of topic trees. Now, it's recommended because a lot of MQTT installations have a factory-specific topic tree set up. The vendor or the factory owner has basically decided they want to have all of their data presented in a certain way because it suits the processes that they need to run. And OPC UA pub/sub allows the publishers to be configured to be published to any sort of topic tree, and so they can integrate nicely in with these factory-specific topic trees. However, if you don't have those kinds of trees in place, or they didn't necessarily required, there's a recommended way to structure your topics, so based on the publisher configuration. So this gives a certain amount of predictability. So you know exactly where to go looking for your data if you understand the OPC UA pub/sub configuration model. And in addition, the pub/sub configuration model, the the MQTT topic tree, the recommended topic tree, provides all the metadata that you need to completely understand the data. And so you can have hybrid installations where you put all your metadata into the recommended tree while you're sending your data to the factory specific tree, and the subscribers can link the two together and be able to better understand the context and the semantics of the data that they're receiving. Now the recommended MQTT topic tree has a format that follows generally well understood conventions when it comes to MQTT topics. You have a prefix defining the scope of the identifiers, an encoding, and then a message type. And then after that, you've got a hierarchy that's based on the pub/sub configuration. The bottom of the top of the hierarchy is the publisher ID. The publisher can represent a device, but it doesn't have to. You can have a device, can have many publishers. In some cases, you can have redundant devices that are publishing to the same publisher ID. These are all decisions that are made by the system architect. The group names themselves, it's up to the system architect to determine what sensible groups what groups make sense for given the data or events that they're publishing, and the dataset writers represent messages that are put on the wire. So each dataset writer has a different set of fields that are bundled into a message and published to the broker. Now, one of the things that people need to be able to do with the topic tree, and this is one of the things that makes MQTT so popular, is the ability to use wildcards in their subscriptions in order to be able to effectively discover what's out there on the broker. So, for example, if you want to find all the publishers that are available on the broker, you would subscribe to the status topic. And the status topic is connected to the last will and testament and would report whenever a publisher goes offline, but it also reports other status information related to the publisher. So if the publisher is running fine, but the downstream source of data is gone, this information will be reported to the status. So this has got a very simple way for you to find out everything in your system, everything out there that's in your system. If you wanted to then find the exact messages that are being published to the broker, you would subscribe to the metadata. And this would give you a description of basically the schema for every message that's published, and you can then decide which ones you're interested in. If you want to limit your query to a particular publisher, you can include the publisher ID in the topic wildcard, and that would allow you to select all data from device 1 or all data from device 2. And there's many other possibilities, obviously. So the message types can appear at 2 levels. So at the top level, the message type is on the publisher ID. You have the status, which is used to detect when publishers appear on the network. As I mentioned earlier, it's connected to the MQTT last will and testament. The application and endpoint information tell you something about the source of the application that's actually publishing the information, as well as the endpoints that could be used for client server. And this is going to be very useful in some cases where the subscriber is getting data and they realize that they need to do something that can't really be done with pub/sub, and they need to switch over to client server. Well, the information they need to be able to do that, they can get from the broker from the endpoints topic. Now, obviously, this assumes that this particular subscriber has got the necessary permissions and network connectivity to connect to the server, but that in some cases that will be true. The connection connection message type gives you all the metadata for all the dataset writers that are published for a particular for a particular publisher. So you can get all that data and then allow you to in a batch mode sort of set up your subscriber as opposed to subscribing to individual topics. And the last one is the node set. This is the node set fragment. And I'll be talking more a bit about what the word fragment means. But it provides basic information model context information. And this is the first part of the links that we're adding between the information models and the data as part of our MQTT mapping. So at the dataset writer level, we've got a few more message types. You've got the data, which is where you're actually getting the live data, which are basically messages that have name-value pairs based on whatever was configured for the publisher. The metadata provides the schema that describes the data that's published. So it is the minimal amount of information. It's basically the names of the fields. So it says the data message will have a field X and a field Y, and X is an integer value, Y is a string, and oh, by the way, Y has some engineering units, and this is what those engineering units are. So it's basic information that is useful to a subscriber. Now, if you want the complete context of where this data is coming from, the source provides a mapping between all of the fields that are in the data message and nodes in the node set that was published at the publisher level. And so this is the sort of the first breadcrumb. So you get your data, you can get your metadata, and you go from your source, and that allows you to go back to the node set and get the actual nodes. So the node set fragment, the reason we have to have a node set fragment is MQTT brokers have a maximum message size. And if you just throw all your nodes in there, that message limit is going to be blown up. So there's a need for some logic in the publisher to create a subset. And typically this will involve going up one level, going down one level, and that will give some reasonable context in most cases. In other cases, the publisher may want to add more information, but that judgment is left up to whoever's creating the configuration for the publisher. So the important thing, though, is the node set fragment leaves out all the types. The types are never included in the fragment, but the node IDs that reference the types are there. So these node IDs will be links that we'll use to go look up that information elsewhere, and I'll talk about how to do that in a bit. Now, the minimum information you have to have is, of course, the node that is the source for every field that's published in every data set. So so that information shows up at from the source message type at the data level, which I mentioned in the previous slide, and that links back to the nodes that are in the node set fragment. Now, you don't necessarily need to include some of the properties such as e-range and these kinds of things in the node set fragment if you have included it in the metadata. So the metadata has this ability to include immediate properties of each field if these properties change rarely. So it's good for stuff like engineering units, it's good for value precision and a few other things that are all defined by the specification. So those nodes, if you're putting them in the metadata, don't need to be in the fragment. But you can leave them there as well. Either it's a judgment by the configurer and we will eventually develop a number of recommendations and guidelines for how people can put this together, and preferably there will be some sort of standard algorithm, simple algorithm to give you the basic set, useful set. So you've done that, you've got your node set fragment, you're publishing to the broker, the subscriber gets this information, it follows the breadcrumbs, it gets the metadata, gets the source, gets the node set, and it says, great, I've got this information, but it's not enough. How do I get the rest of the information? Well, there's a couple options. The first option is the subscriber is pre-configured with a number of companion spec node sets, or basically all the node sets that the system is known to be using in some sort of local cache. So it can use the namespace that's associated with the types that show up in the node set fragment to find the complete definition of these types in their local cache. But there's another option, and that has to do with the UA Cloud Library, which is another specification that has been recently released, and it now has working examples online. And this is a library that provides REST interfaces that stores information models, like basically node sets, that can be queried by clients using either simple queries with namespace URIs or complex GraphQL queries. It's a powerful standard, but for purposes here, all you really need to do is go take the namespace and say, give me the node set, and you can download that. Now, for static node sets, particularly the ones that are defined by the companion specs, that works reasonably well. But the cloud library also allows the publisher to upload its server-specific node set. So as part of its configuration and setup, the publisher may have a number of different types that it's using. It can then upload those types to the upload a node set that defines those types to the cloud library, and then the subscriber can now get those types from the cloud library. So you have the subscriber can now reconstruct the address space from the publisher that is being used to describe the fields that are in the messages via these node sets that it collects from the cloud library or its local cache. It provides a complete context and semantics, and this is going to be a very powerful tool, especially for more complicated analytics engines that need to understand the semantics of the data they're getting. It's going to be a valuable tool, especially when you have many different publishers using the same information models, because they're basing their server address space on a standard companion spec, and now you've got this integration between these disparate sources that may be coming from different devices made by different vendors that are all producing the information that is all described in the same way. It's a level of interoperability and semantic interoperability that hasn't existed before. Another feature that is part of the MQTT mapping is the ability to invoke methods via the broker. And we're calling these things actions because they're not exactly the same as methods. But it has the topic names follow a similar pattern in terms of how they're laid out. And so the action itself, the action group name can represent the object that you're invoking the action on, and then the action name can represent the method name. Or it could be the reverse. The action group name could be the method, and the action names could be a bunch of objects that you are doing the same action on, or calling the same method on. It's really up to the system architect to decide the appropriate representation for each of these things. So what happens here is we're leveraging the standard reply topic, which is part of MQTT 5.0. It's put in the header that basically says this is where the response goes to. So you send the network message to the publisher's action topic, and it gets this message. It processes the method, and then returns the response back to the topic that was provided in the request, and then the caller eventually gets a response. Obviously, this is a completely asynchronous operation because the broker itself is completely asynchronous. So there's going to be certain classes of methods which aren't going to be appropriate to model in this way, but it will be useful in enough cases that it will be a powerful capability in a lot of systems. Now, the message types for actions include the action request, which is a topic where things are being sent, and this is where you basically bundle up your request parameters and you send them to the publisher. The action metadata is the metadata that describes the contents of the request message and the contents of the response, and plus some other metadata about the method being invoked. And so this basically metadata gives the subscriber, the caller, everything that they need to know in order to construct the message and understand the response. The action source is the breadcrumb that links you back to the information model. So basically, because all these actions map onto an object and method in the address space, these action source tells you what exact object and what method that the action is based on. And so they would link back to the node set fragment, which in turn can be linked back to a type model, which can be downloaded from the UA cloud library. Now, obviously, actions are privileged operations. You don't want to have anyone changing the state of your publisher with the invoking action. So you need to know who's doing this. Now, in many cases, there will be ability within the broker to restrict access to particular topics, and you can use the broker to restrict access to these actions. But it's also useful for the actual publisher to know who's sending the action, so they can apply their own access control. And it's also could be important for logging. They need to know who sent it, so they can log the action that took place. And to do this, they need to have some way to identify it. And this is where adding a non-repudiation signature onto the message is a simple way to provide this information. And when we're using JSON message formats, there is a well-understood RFC that is used widely for interoperability between websites today, called the JSON Web Token, and it can be adapted and used as the message payload for MQTT. So you basically take the network message that you normally would send out, put it into this envelope that's defined by the RFC, and provide a signature. The header would include the certificate and the chain, so the publisher would be able to use the certificate to determine the identity, and the chain to determine access rights. So it's a very flexible mechanism that allows the publisher to be configured to restrict access to a class of subscribers, and it could potentially tie into its existing security configuration. So it would use the same security configuration that it uses for client server to determine access to the actions. So what are the next steps? Well, MQTT has been part of the specification since 1.04. There are implementations that exist today, and we've been having interoperability events on the web that have been ongoing as multiple vendors are testing their implementations with each other. The topic tree extension is new. It's going to be released with 1.0502. The prototyping is in progress, And the RC for the specification that includes the topic tree discussion is on track to be released by the end of Q2 2022. And that will give vendors a chance to incorporate some of these new features into their implementations, and should allow people to take advantage of it later this year. Thank you very much for your time, and I hope you found the discussion useful.
Randy, thank you so much. I learned a lot. I thought it's called method call, now it's called action. But what I also learned personally is everybody is saying MQTT is so easy, and that's true. You can easily implement it. But if you look deeper behind the curtain here, you see how much different ways you potentially could have to send data, because the payload is agnostic. There is no definition worldwide and users are implementing it with their own mapping. Again, I'm repeating my warning. I expect a zoo of different MQTT mappings. Everybody says it's easy, but in the field you have a lot of efforts to then receive different formats and reconvert them. We will see. I'm heavily fighting and helping to convince the market to only ask for the one and only mapping based on OPC UA over MQTT, because it's an international IEC standard, and this is what everybody has to agree on. Again, my reminder, the big 6 companies, AWS, Google Cloud, IBM, Microsoft Azure, Siemens MindSphere and SAP, have confirmed to either already have it implemented or they are supporting it in upcoming future. It's on that technical roadmap. Please join the demo. We already have a couple of controllers and devices pushing out exactly OPC UA over MQTT in this mapping. Again, Randy, thank you very much for your background deep dive presentation here. Next speaker, after the cloud topic, now we are coming to the field topic. I'm handing over in a second to Peter Lutz, the director of the Field Level Communication Initiative. They extended OPC UA with all requirements which are in the field, with deterministic, real-time, safety, motion. It's not only focused on TSN, this is a side effect. It is included for deterministic real-time, but it's also for horizontal, fast UDP communication and looking for Ethernet APL, 5G. This is also what we get a lot as questions. Everything what is related here from the field level, this is coordinated under the roof of the Field Level Communication Initiative. I'm handing over to Peter to share details on the current status. Peter.
All right, so let's get started. First of all, I'd like to welcome all of you to my presentation about extending OPC UA to the field. I want to talk about the technical concepts that we are elaborating. I want to talk about the current status of the work, and finally explain the further roadmap. Let me quickly switch off my webcam so you can concentrate on the content of my slides. And before we go into the content itself, let me first of all explain to you 2 terms that we are using when talking about extending OPC UA to the field. The one term is FLC. It's an acronym that stands for Field Level Communications, and we are using this term whenever we talk about the initiative and the related technical working groups of the OPC Foundation that are responsible for extending OPC UA to the field level in factory automation as well as in process automation. We have a second term. This term is FX, which stands for Field Exchange, and we are using this term whenever we name the technical extensions or the specification enhancements to the OPC UA framework in order to meet the diverse requirements for field level communications. So we name them OPC UA FX or UAFX as a short form for this name. Now, in order to extend OPC UA to the field level, I think it's clear to all of us that we have diverse use cases, diverse requirements to be met. So for example, we have to extend OPC UA to support functional safety. We have to ensure deterministic transport and real-time behavior of the networks. And we certainly have to cover all the specific application areas that we find in factory as well as in process automation, such as field instruments, remote IOs, or motion control, for example. And we have separated the technical work in two, let's say, phases or two categories. The one is the controller-to-controller use case. This is the horizontal communication, the connectivity between the different controllers of different manufacturers. And then the extensions of these concepts are then covering the controller to device, including device to device use case. And this is then finally bringing OPC UA to the various field devices. Now, the OPC UA FX specifications that we are currently working on, they have the part numbers 80 to 84. So it's actually 5 specification parts that first of all have the focus on controller-to-controller communications. These specifications are used on the one hand side now for the prototyping, but also in order to create test specifications. Furthermore, these specifications are laying the foundation for future specification enhancements to meet then controller-to-device and device-to-device use cases. Now, with this slide, I want to explain to you the overall technical solution approach. First of all, OPC UA FX is based on conventional OPC UA technology, including client server, including publish subscribe, including the built-in security, the information modeling, as well as the DI specification part 100. The part 80 of OPC UA FX gives an overall introduction into this architecture. So this is helpful to get an overall understanding. We then have part 81, which is specifying the information modeling of so-called automation components and how to build connections between such automation components. In part 82, we talk about networking. Specifically, we describe how TSN is being integrated into the overall system architecture. We have part 83 talking about offline configuration. We have part 15, safety, which is an important element in order to cover functional safety. And finally, we have part 84, which is defining all the mandatory elements in order to create a concrete controller implementation. So it's mainly referencing to the various OPC UA parts, but also to external standards such as those out of IEEE. When we have a closer look at the key concepts, there is first of all the information model for automation components, which is specified in part 81. And we distinguish here an asset model as well as a functional model. And important is that by harmonizing these models, we finally have a uniform access to the information provided by the various automation components, and we become independent of specific controllers or device implementations. The asset model is describing the world of things. So these can be physical things like hardware or hardware components, but it can also be software, firmware, or even licenses. It offers nameplate information about vendor, product, firmware version, serial number, and so on. And it's based on the DI and asset management specifications, parts 100-110. Important is that, as already mentioned, it allows the extension with existing companion specifications, and just to name one example, the P8M specification for the process industry. We then have the second model. This is the functional model, also described in part 81. It describes the world of functionality. And this can be as simple as a digital input or digital output or a temperature sensor, but it can also be as complex as a servo drive with a lot of different input and output data, including state machines and including sophisticated diagnostics. Again, extending with existing companion specifications is important. You know that also the VDMA has elaborated a wide range of companion specifications that are complementary to the functional model we are elaborating for OPC UA FX. Another important element of part 81 are the so-called UAFX connections. These are connections built upon OPC UA PubSub in order to exchange data between functional entities. And these functional entities, as you have already heard, are part of the automation components. So by using these UAFX connections, any kind of process data can be exchanged. It can also include safety critical data, and it supports the different existing security mechanisms of OPC UA, such as authentication and encryption. Very important is the so-called quality of service, which allows different types of data to be exchanged. Especially important is the exchange of real-time data, where we have to have a certain latency guarantee, a certain deadline guarantee. And this certainly therefore includes an underlying Ethernet TSN network for deterministic communication. As already mentioned before, offline engineering is an important element of UAFX. The concepts for this are described in part 83. The central element are so-called offline descriptors that describe the capabilities and the functionality of the automation components, also including configuration information and asset information. This offline descriptor is being used through the different life cycle phases of automation components. So it's been used In the development and the engineering phase, it's used in the commissioning phase as well as during operation and maintenance. The concept is based on the Open Packaging Convention ECMA 376, and this means you can combine different files, different attachments in one single document. You can also build relationships to internal and external components, and it includes also digital signature. The information model is described using Automation ML, which is an IC standard 62714, and you see here on the sketch on the right hand side that the descriptor can not only include different information models but also any other kind of attachments such as manuals, drawings, and so on. Now on this slide here you see how these offline descriptors are being used. First of all, by engineering tools that are importing these offline descriptors. Then the connection configuration is being created and generated out of the information that is provided. In the third step, the connection configuration is deployed to what we call the connection manager. And this connection manager is then managing and handling the connection configuration set. There's also the possibility to modify such configurations by system integrators in order to adapt a certain configuration, a certain installation in the shop floor, for example. On the slide here, you can see how the connection manager is then calling so-called established connections in the different automation components in order to set up connections between functional entities. Such connections can be between functional entities within one automation components or connections between different automation components. And the connection manager can be also part of a specific device. Like you see here, it's what we call the internal or integrated connection manager. There's also the possibility to have external connection managers that are then activating the connections in other external devices or controllers. Again, the connection manager calls the established connection, and then the connection is built between functional entities. This is completely flexible, so also dynamically additional connections can be set up, like for example here between automation component 2 and automation component 4. So far I have mainly been talking about the base concepts of UAFX, including automation components, the offline configuration, as well as the UAFX connections. However, we are also working on extensions to these base concepts, and these have to do with device-specific or use case-specific models or protocols on top. For this, we have established different corporations. For safety, we are cooperating since several years with Profibus International, and for motion, we have established a cooperation with the ODVA and Sarcos International. To quickly update you on OPC UA safety, we already have published 2 specifications. This is part 15 of OPC UA. In the release 1.04, we cover client-server communications and do not yet support real-time communication. In the release 1.05 that was published in November last year, we extend the concept also for publish subscribe. So this matches the UAFX requirements for supporting controller-to-controller communications. You see on the right-hand side the concept, which is having OPC UA safety built upon the underlying communication. We are using so-called OPC UA mappers to map to publish, subscribe, or client server, and then the safety data is exchanged over standard communication channel. This is also known as the so-called black channel. We have ongoing projects on the one hand side to create test specifications and a test tool which will allow us to test and certify safety devices, and we are also working on an implementation of a safety stack that can be used by companies for commercial products, but that will also be made available as open source. Future work is about extending to the use case controller to device, C2D. Especially we need to define how the parameterization is done in a safe way. With this slide, I want to give a quick update on the UAFX motion activities. The motion working group has been established in June 2020. The working group is elaborating the motion specification based on zip motion and Salcos, and these existing concepts are changed and extended so that it fits to the OPC UA and UAFX system architecture, and it also supports the different use cases out of the IIoT and Industry 4.0. The first specification is currently in work, covering servo drives, so the closed loop drives, as well as frequency converters, also known as open loop drives. As I already explained before, the complete OPC UA framework and also the extensions defined by OPC UA-FX are transport agnostic. That means they can be mapped to different underlying transport protocols and networks, including different physical layers. So I want to talk in the following a little bit about the importance of two technologies. Specifically, this is Ethernet TSN, time-sensitive networking, and the advanced physical layer. Ethernet TSN is an extremely important element in the overall technical solution approach because it supports deterministic communication over standard Ethernet hardware, but at the same time TSN supports the so-called network convergence. This is allowing different IT and OT protocols sharing a common network infrastructure. For this, it's important that we define a common profile for TSN, and this is done by the IEC IEEE 6802 standardization group. In the context of TSN, I also want to mention the conformance collaboration that we recently established with other non-profit organizations. This collaboration is about developing a common and a single conformance test plan for the 6802 profile in order to ensure that 6802 compliant devices that come from different manufacturers that support different automation protocols reliably can coexist in a common and a shared TSN network. Further information you'll find by following the link below. A few words about Ethernet APL, the advanced physical layer, which is another key technology to bring OPC UA to the field level. Ethernet APL is two-wire Ethernet for the process industry. That brings Ethernet also in hazardous locations. The technology launch was back in August 2021. Now first field devices and infrastructure components are available, and we are currently preparing our OPC Foundation certification lab to be able to do APL testing. This will be in a first step mainly about devices that have OPC UA as a second channel. So mainly using OPC UA for diagnostics and monitoring. But we have also first prototypes that use OPC UA as a native interface, also for exchanging process data. Now, after talking about the theory and the concepts that UAFX is adding to the OPC UA framework, let me talk a little bit about a real multi-vendor demonstrator that we have been realizing end of last year. You see here overall 17 controllers here in the upper part as well as in the lower part that are connected with each other using OPC UA and UAFX extensions. They are connected over a common network infrastructure that you see here in the middle section. This consists of Ethernet switches, Ethernet TSN switches, as well as of a 5G testbed. We are using two dashboards on the left and right hand side for the visualization, for the monitoring of all the communication and the different connections that have been set up. But we also use these dashboards to configure the UAFX connectivity between UAFX controller prototypes that then exchange process data with each other. Okay, talking a little bit about the roadmap for OPC UAFX specifications. We are currently finalizing the specification version 1, which has the focus on controller-to-controller communications. We plan to start the final member review end of May, and this includes all the parts that I was explaining before, parts 80 to 84. This is the so-called release candidate 3. We can expect a final and public release available in the third quarter of 2022. We are currently preparing for the kickoff about extending the concepts for controller to device, including device to device. This is the so-called specification version 2. The kickoff is planned for end of July at Schneider Electric in Andover in the US. And all OPC Foundation members are invited to participate. Okay, with that, I'm coming to the end of my presentation. I would like to thank all of you for your attention. I'm providing here some contact information as well as links in case you're looking for more information. And I want to also mention that we will organize a 2-day webinar, most probably in June, where we explain further details of the technical concepts, where we have our working group chairs, our technical experts, giving you a technical deep dive on OPC UA-FX. Thank you again.
Peter, thank you very much for your overview. I'm really thrilled to see the demo in Hanover at the Hanover Trade Show. We reserved a big space for that demonstrator. I remind the audience to join the OPC Foundation booth in Hall 8. It's also showing OPC UA safety demo and the cloud demo and the GDS and collaboration, so you have to join. But again, I want to seriously thank definitely and specifically all the companies being active in the steering committee, because this initiative is driven by the industry. So it's 27 companies. Overall, there are 320 experts meeting regular and cyclic to extend OPC UA to meet all requirements for the field level. So it is solving really topics which are not available today. Remind two machines in a factory, in a plant, talking horizontally to each other. There is not a real solution combining the different ecosystems out of the box with standardized included security and so on. So we are looking forward, and again, thank you very much to the community here. Okay, so that was the day. I like to thank everybody here. First of all, I like to thank here the speakers of the day. What I was really thinking about, today there have been more attendees than yesterday during the presidential talk. I was a little bit astonished, but obviously Peter may think it's because he presented field today. My feeling is it's because of Randy. He gave such deep details on MQTT and security together with Mr. Cordt from the BSI. Maybe next year we can do just 1 hour on ask questions to Randy, right? And we don't have to prepare any slides, and it's just Randy being online and available for 1 hour. Maybe we can even run that twice a year, and it would be a super successful webinar. So I'm thinking about that. Randy can comment that. Randy, thank you very much for staying online. Have a good night. But I like to make a short statement to the end here. So thank you very much for the day. It was day 2. We had exceptional, great, fantastic presentations on security, on cloud, MQTT, mappings, and field. I like to thank all the speakers, but also obviously the audience. It was a great Q&A session here also. Alexander, thank you for moderating and handling this. Please stay tuned on day 3 tomorrow, where we are talking about all the semantics and with our cooperation partners, defining the semantic in different areas. Have a good day, have a good morning, good evening, good afternoon, good night, wherever you are in the world. Bye-bye.